Some factor question. Okay.
Okay, hang on. This is for part 4.
Yeah, okay. Yeah, okay. Right, okay. Okay, sure. So you got 1, 2, 3, is it? Is that what you're saying? Oh,
Yeah.
this is that thing. But yeah, this is that question. Okay. So you're saying part 4, all right? And then
Yeah, I managed to. Okay, so I got like OC and I got BC, and that's what the answer key got also. Then the method is the same, but the difference is for this normal, I used OC. I used OC to find the normal, but the answer key used BC.
that feels very different. Yeah, that feels very different.
Yeah.
That's the question.
Yeah, that's the question.
Okay. Do you have any drawings that you use first? By yourself? I mean, you draw yourself.
Okay, I think I can just put it in there.
Okay, so it was the same question. So I'm going to be, okay, good, wonderful. Right, so let me confirm a few things. Yeah. So you have your point C, which is previously not. Yeah, okay, so C is new, can understand, and your OC is correct, good. And as a consequence, your BC is correct. So that's natural, right? If your OC is correct, your BC is correct, because B is somehow given.
Yeah, they're both correct, yes.
And A is also naturally before this question already, right? Right, yeah, it should be like, okay, right, understand. Yeah, because there's given, obviously, right? Okay, good. Right, and then F was A to pi, you already know pi. So just curious, what is F?
Foot of perpendicular, it's
Yeah, so it's in the coordinate.
like coordinate. Hang on.
And where is the L in your drawing, right? So I'm not seeing any L in your drawing.
The L is like up here. It's kind of cropped out, yeah. So it's up there, this one.
Oh, the L is parallel to, okay. So there's an L there, right? And this L is the guy on top, the 301 thingy, right? Oh, 30, oh, the L actually contains B. No. Wait, yeah, the L actually contains B. So your drawing is a little bit off. The L contains B.
Oh yeah, okay.
Right. So I think let's fix that. Maybe that's important, maybe not. Okay, but let's fix that. Okay. So we just add it here, right? Okay. So the L contains B, right? So for the plane that contains C and L, right? So when the B1, oh, you just extend the B. Don't just lower the L. No. Just lower the L. Just lower the L. That would be better, right? And then the L somehow has a direction factor of 441, right? 441, right? That's what the L looks like. May I know what's the normal of the plane? Just curious.
The new plane or this current plane?
The
The
current plane. the plane that contains the plane pi lah, the plane pi. That's what's the normal?
Where is it?
Yeah.
Find it. Okay, 2.
Two minus 3 minus 1. Minus 3, 4. So I'm just checking whether we are missing something or not. That's what I'm doing now, because the drawing is always important. And then according to the drawing, now we can imagine the plane that contains C and L, right? Okay. So basically we imagine a plane which is rotating on the line, correct or not? The line is the rotation of the plane, and the plane rotates until it touches, until it contains C. Do you understand what I'm saying? That's how I would imagine the plane lah, so far.
Okay.
Am I making any sense right now?
Yes.
Right. So like that. So I'm just doubling the line here. So I'm imagining that the plane can rotate, right? And then it will finally contain C, which is kind of like maybe a little bit down there. Okay. Now, it should already be clear that BC, because B is on the plane, right? Yeah, B is on the plane, isn't it? Correct. B is on the plane. Clearly, B is on the plane. Because line is on the plane, L is on the plane. So B is on the plane. Are you okay with this?
Yes.
So BC cannot be the normal of the plane. That doesn't make sense, right?
Yeah.
Right. So are you saying that when he finds the normal of the new plane, he's crossing BC?
Yes.
It makes sense, to me. It makes sense to me. It makes sense to me to use BC. I'm not sure about OC because it doesn't feel like OC it's contained in the plane, so there must be another reason for using OC, right? Now, the 441 is, oh my goodness, it's very clear that I agree with him, right? Because 441 is this vector, isn't it? The vector of the line.
Yeah.
So it's very clear that if you cross BC and the direction vector of the line, you will get the normal of the plane. That's very clear to me. It should be clear to you also. I'm not saying that your answer is wrong. I'm saying that the answer key seems correct. So far, so good. If that makes sense to you.
It's not very obvious to me.
All right, let's start with this again. Let's talk about the original plane pi, right? So you will find the normal of this pi by crossing these two things, correct?
Yes.
But why do you do that? Because this is contained in the plane and this is contained in the plane. That explanation is not enough for you, isn't it? That worries me a little bit.
I mean, the question just said it contains C and L, like,
No, I'm referring to the original plane first. Why do we find the normal of the plane, if you want to, right, by crossing these two vectors? Why does that work?
How does that work?
Yeah. Why does it work that if we want to find the normal, we cross these two things? Oh dear, this is definitely a gap, isn't it?
I don't know how to explain it. I mean, from how I understand it, at least, it just looks like
it just looks like it works. Correct?
Like two lines expanding outwards in my brain. And then it forms like and then kind of encloses a plane, I guess. That's what it looks like in my head.
Correct. correct? So talking about the original plane, right? Original plane, right?
Yeah.
You will expect this direction vector to be contained in the plane, right? And this direction vector to be contained in the plane also.
Yes.
So when you say you expand that two direction, you will get the plane, correct? You will get the plane.
Yeah.
Now, therefore, when you cross product these two, you will get another vector which is always perpendicular to both, right?
Yes.
Perpendicular to both, in this case, will always means perpendicular to that plane. And therefore, normal lah, by definition. That's why crossing two vectors, which is contained in a plane, will always give you the normal of that plane, which is what we usually desire, the normal. This, if you're okay and if you understand this as basic, I'm very happy to continue.
Yeah.
Okay. Then I'm very confused why my explanation for part 4 does not seem to work. I haven't explained why OC is wrong, okay? I only explained that BC is contained in the plane and 441 also is contained in the plane. And therefore, finding the normal with these two will work.
Yeah, that one I agree.
Okay. So the answer is C, correct. So why does OC not work? If you want to know more, right? So back to the drawing. So I'm not sure where is O though. So what is OC? OC is 3 minus 3, 6. At this point, I have to try very hard to imagine where is O. Since I cannot, I will end up imagining it in a random position. Apologies, that's what I can do because all our drawing is a little bit random. So this is O, right? Therefore OC, right? There you go. That's the OC. So your proposal for finding normal is to cross this thing with that thing. Correct? That's your proposal. It will not give you the normal of the plane. If you find that to be very a happy explanation, then we're done. If not, then we'll try more. We'll try to explain more if you're not happy.
It just says like contains C and L. So like.
Yeah, and C is not OC. You're wrong.
Contains C is not OC.
OC, because in the case of finding the normal of the plane, you need two vectors contained in that plane. C is contained in that plane. OC is not. You have that happened last time. Maybe this is your gap. C is not represented by OC. It's really not represented by OC, even though they have the exact same number. So if I write OC, well, C is 3 minus 3, 6, isn't it? Ooh,
yeah.
My pen, don't stop working. Not stop working. When we need you the most, don't stop working. And the vector is 3 minus 3, 6, right? So what should be confusing to you is that BC, what is BC? I have no idea what's BC, but just tell me what's BC. Just tell me what's BC.
Yeah. BC.
All right, so I'm going to write here 0 minus 3, 5, right? Right. How? OC and BC does not seem parallel at all.
Yeah.
Okay, I'm trying a few ways to explain to you. Yeah, BC definitely is contained in a plane. That one you cannot argue already. Even if you don't disagree, your brain must adapt.
Okay.
Correct or not? Can you? So if BC is parallel to the plane or contained in the plane, they are basically the same thing. OC is not. Look. Even though C is contained in the plane. So what you should have thought is more like B is contained in the plane, C is contained in the plane, therefore I can use BC. I can also use CB.
So I should just try to find like 2 points on the plane, then find a direction vector.
Yeah, a vector, just a normal vector. BC lo, CB lo. This is not theoretical. I actually hope that you don't understand it as a memorization. It's a bit dangerous. The point is, OC in the drawing is clearly not in the plane. Clearly. Clearly. But BC is. Put it another way, C is in the plane, O is not. I'm not sure. Maybe that's the thing that's helpful to you. But BC,
I think
B
that
and C
makes
is.
sense.
Yeah, okay. Okay, then let's use that. So OC is not usable because O is not on the plane. Same thing with OB. Same thing with OB. What do you think? OB also not usable.
Yeah.
But BC is. Okay. Maybe we found a good explanation.
Yeah, yes.
Okay. So that was the question, yeah?
Yeah, then part 5 also.
Let D be the point on the L. Okay, sure. Find the largest possible value of the non-reflex ABC. Again, I'm not seeing a drawing here, so I'm not the happiest. I think you should draw D at least, At least.
Draw D.
I mean, it's randomly somewhere, but it's somewhere on the line, right? Hey, the line is the new guy. No.
Oh, right, the new one. ADC.
AEC. Okay. Is that A? Okay, that's that. Is that really that's A? Okay, right. Okay, that's ADC. Okay, looks fine to me. Right. So he wants the largest possible value of the non-reflex. Okay, understand. Okay, so it doesn't seem very straightforward, right? Apparently, to the question, it looks straightforward, apparently, yeah. Apparently, right? Okay, so we have to do a little bit of imagination. Are you saying that you cannot start at all, or you're just stuck in the middle?
I found an expression for like what DA and DB, but it's
DB. Why would you need DB?
Is it DB?
Why would you need DB? I would think you
Oh,
may
DC,
want
sorry,
DA and DC.
DC,
Okay,
sorry, DC.
Okay.
Then,
Yes,
but yeah, it's just like
the D should be the line, right? That's all you have, right? Your D is actually just the line expression.
Then I found DA, DC.
Then you kind of you can cos, I guess. You can dot product them, basically.
Yeah, I dot product, but it's
some sort of equation in T, I guess.
Yeah.
Maybe even a quadratic equation in T. Is it quadratic? Just curious.
Yeah, seems like quadratic, yes.
Okay. Then a quadratic always have a maximum or a minimum, depending on the type of quadratic. Right? Let me put it another way. The quadratic, the dot product will be equal to, the dot product. Okay. So the dot product, the quadratic, I'm going to write down. The guy quadratic will be equal to the length of the first guy, length of second guy, cosine theta, right?
Yeah.
Right. So if I want theta to be largest, correct? If I want theta to be largest, then I want cosine theta to be smallest, correct?
Yeah, correct? I guess, yeah.
So I want I'm hoping that the quadratic has a minimum value. I'm hoping. So I'm hoping that the quadratic is a smiley, not a frowny. hopefully lah. And you can tell immediately by just looking at it. Am I making any sense here?
Wait.
Because I cannot see what you're doing. So why don't you just show me what you have done? And easier. We need space, so I'm going to erase all that. Space, erase. Okay.
So I find an expression for cosine theta in T.
Yes, as a result of the dot product, it's supposed to be a number, right? But number that varies because it's a quadratic.
Yeah, it's all
right?
in T. Yeah.
Right. So, and then we notice that the dot product is actually equal to, the length times the cosine theta. So you can say, yeah, the cosine theta is going to be that quadratic over length, whatever, right? Whatever.
Length. Wait.
The length, right?
Interesting.
I suppose you need to include the length. I'm so sorry. What am I talking about? You need to include the length because the length varies. What am I talking about? Right? You need to include the length, right? So everything is an expression of T, and now it's not very tidy. When it is not very tidy, the best thing to do as an A-level student is to make full use of your
GC.
Yes, and I will do that now. I will find the minimum value somehow from all this thing. All this. Now it should look like a mess.
It is a mess, yes.
Correct. But if you graph it, we don't care. The graph actually is usually not a mess. The algebra is a mess. Our brain cannot wrap our head around it. And surprise, we are not always asked to wrap our head around the algebra. Sorry, I forgot to mention that we have to include the length. Right? So yeah, I would predict that that's the way to answer.
This is a quadratic. It's a very strange looking quadratic.
It's no longer a quadratic, no, because of the quadratic over the the length, one Pythagoras, another Pythagoras. So it's not gonna look nice already, but who cares? Can we tease a minimum value out of all this?
That it looks like there's a minimum. Yeah.
Right. So a cosine theta only accepts from -1 to 1, but even then we're gonna reject the -1 to 0 because he wants the non-reflex one. If it is, I'm sorry, if it is reflex, it may still be -1. I'm so sorry, what am I talking about? It can be quadrant 1, it can be quadrant 2, it can be quadrant 1, right? So I'm so sorry, we need to include the from -1 to 1, the possibility, the range, right? And need to choose the value which is the smallest, which is the closest to 0, basically. Is the closest to 0. Never mind, just show me the graph. My goodness, right? Just show me. Either show me the algebra or show me.
Okay, wait, no, let me fix some stuff first. I feel like I made a mistake.
Okay.
Okay. Yeah, I have to.
Keiko, just checking you okay, yeah?
Yeah, I'm typing in
Right.
the
Sure.
new one now.
No worries, no worries. Ainesh, very happy to see you. You're the earliest today so far, yeah? Can you hear me nice, loud, and clear?
Yeah.
I can hear you clearly also, right? So let's hope that continues today. But still, we will start when we have, in this case, no video we're talking about, right? In this case, we will start when you're connected to a Jamboard. And then you will also screen share lah. I mean, we'll go back to screen sharing lah, right?
Are we doing science or math?
Hopefully math. Kyoko is just a little bit late today. So yeah. I'm gonna give you a head start on the next question.
Okay. I'll take photo of the graph.
Can with a clear x-axis. Yeah.
I'm on the Jamboard.
You're on the Jamboard. I'm gonna paste a question very, very soon. I wish you could do this, right? The next one would be much easier, right? Oh, that's so weird. Okay, wow, that's weird. Okay. I wish you could do that.
The minimum for my cosine theta is -8.
-8 is out of the range of cosine theta, right? Cosine theta should have between -1 to 1. So that's the first thing you must consider, right? So we just look at the range of from -1 to 1. And that's why we need to have a clear sense of the y-axis, right? So just look at the y-axis from -1 to 1. So zoom in if you have to lah. Obviously, in this drawing I'm looking at, I cannot tell where is -1 and 1. Makes sense, yeah? Okay, so Ainesh, I have a new question for you in page 13, right? I need to see your screen sharing and I need you to work with your Desmos lah. This is easier than yesterday's question and it is very similar lah, right? So Ainesh, your screen sharing.
Yeah.
You have a new drawing, not yet, Keiko, yeah?
I see my screenshot.
Yes, I see it now, and you're seeing this question, right? I'm asking you to do two things, right? I'm asking you to do the Desmos, and I'm asking you to present it properly. Those two things are what we're doing today, same like yesterday, right? Log into your Desmos, right? Log into your Desmos. Make sure to refer to yesterday's if you don't understand. This is not yesterday's, right? It's not yesterday's.
I didn't see yesterday's.
Okay, right. Better be able to repeat them yesterday, right? Okay, but right, go back to reading today's question first. Ask me what you don't understand, and then try to do it in Desmos. That will be my suggestion, Desmos first, then present. Right, Keiko, do you have a new? Oh, you have a new picture.
There's no function for finding an x value from a y value?
You can zoom in. So that means instead you will limit your screen to a certain range.
Yeah.
You
But-
can do that.
I still can't like get the exact value.
You can. You just intersect. If you, for example, you want the intersection with y equals to minus one.
Okay.
Just the minus 1 or 1. Right? So that's what you can do. Right. So you tell me, Ainesh, what is the meaning of the question lah? Find the equation of the normal.
mean?
All right. So yesterday, did we do normal?
Yes, but I forgot, I think. I forgot normal.
That's not okay. So redo it in Desmos yesterday.
Redo yesterday's question.
Yeah, in Desmos though, because it's a very visual thing. I don't mean the algebra. I don't mean the answer key. Yeah, the answer key is no longer valuable. I mean, try to plot yesterday's curve in Desmos, then do the tangent, and then do the normal. So curve, tangent, normal, right?
Oh, it's going to take so long.
That's because you're not comfortable with Desmos. I'm trying my best to make you comfortable. Please be on board, right? Please be on board with this. If I teach you the answer key only, do you think it'll be better for you? That means all the presentation, is it better for you? Let me try to imagine.
I'm not a very visual person, so it is actually harder for me to do Desmos. So maybe it would be better for me.
Right. So let's go. Let's go to the question. Let's go to the question 1. The previous question quickly. Right. Imagine a very general curve, right? Just a very general curve, and imagine the tangent. The tangent is glancing. Okay. So far so good.
Yeah.
So not this. Right. So the one before this, right? Okay, let's gonna stop here. Yeah. Okay. Find the equation of line that is parallel to the tangent, whatever. So you have to imagine a tangent to the curve, right? A glancing line. Can. So at x equals to 1, and then suddenly at the second part of the question is normal to the curve, right? So imagine that the glancing line now have a perpendicular line. I draw it there. I'm so sorry, you cannot escape from a minimum visual. So the minimum visual is there in front of you. In front of you, meaning this guy. I'm sorry. Let me use a laser pointer. This guy. This is the glancing line. And this is the normal. The normal is 90 degrees to the glancing line.
Okay.
Right. So that's the normal. That's what they're asking for in the new question. So that will be the start. What do you think, Keiko? Are we getting something here?
Wait, so how to say? We're gonna take the minimum cosine theta value as -1, right?
We need to look at the range from -1 to 1. Yes. Oh, it's very symmetrical, isn't it?
Kind of, yeah.
Mm.
And then
I'm a bit uncomfortable with the graph, isn't it? It implies that there is a 0 value, right? It implies that cosine theta can be 0, isn't it?
yeah.
So it can be 90 degrees. It can be 90 degrees. Let me think for a while. Is there something bigger than 90 degrees here? It can be, right? It can be. So if cosine theta is equals to minus -1, is that what he's implying? That cosine theta can be -1? Cannot be, right? What's the most minus y value, right?
-8.
Which does not make sense, right? So -1. So -1. So the cosine theta can reach -1, right?
Yes.
That's what so it implies that your theta can be 180, which is extremely weird. What's going on here? Why don't you show me the equation again, just to check, right? Why don't you show me the equation? Let's just take a picture of it. Okay. So Ainesh, let's say you skip Desmos, right? You go back to page 13.
Now this one I have to do on Desmos, right?
If you want to, I think that's better, but nobody stops you from doing it the other way lah. So let's say you want to do the algebra first and then you confirm with Desmos. I'm actually okay with that lah, as long as you do both, right?
How do I even do the algebra? How do I calculate the tangents?
It goes back to the job of dy dx. What is the job that you want dy dx to do?
Oh, that would be very complicated.
No. Your thinking is off and totally unsuitable lah. What is the job of dy dx?
It's to find out the tangent equation.
The gradient of the tangent. The gradient of the tangent lah. Right? Now, how complicated is that?
Pretty complicated.
Your thinking is way off already. You look at y, is it that difficult to dy dx?
Oh, no.
So dy dx lah. You need it for this anyway, right? Anyway.
Yeah.
Do I see the equation? There you go. Okay, I see the equation now. Oh, I'm very uncomfortable with your equation. Your equation is on frowny, right? Right. This cannot be true, yeah, Kiko. Okay, give me around a few minutes to test with my own Desmos, yeah, Kiko.
Okay,
if you have something else to do, that would be nice. Yeah? So I need you to start with a dy dx. I keep asking you to do this step because you seem to be resistant until 3 times. This is not
I am doing it.
Knowing the best. Yeah, where are you doing it?
Can you see it on the screen?
Right. Okay, now I can.
Wait, what? No.
So your differentiation result seems okay, right? You're setting at x equals to 1. Ooh, all right. Okay.
Question.
I can see why. Right? So I will argue that at this point, if you use algebra, it will be easier for you lah. Then you just confirm using Desmos. Maybe that's just more suitable for you. Why don't you use your algebra? It's not very difficult to deal with 4x minus 3. Ma. Can you ask your dy dx algebra, not Desmos, to give you the gradient of the tangent line?
No, I don't know how.
You keep saying that, but we're doing that for the past 2 days already.
Like, I know how to use Desmos.
I'm not asking you to use Desmos. I'm asking you to use the algebra. That means your Jamboard. Your Jamboard, please. Your Jamboard, please.
Okay.
You have dy dx equals to 4x minus 3. What is the one job that dy dx can do?
Find the gradient of the tangent.
At what point?
X equals 1.
No, at any point you want. Including x equals to 1, including that. So why don't you write in your presentation here, I want to find m at x equals to 1. So how are you going to do that? Yoko, okay, I can see you now, yeah? So either share your screen or turn on your video, yeah? Either one. Why are you looking at this, Ainesh? Why are you looking at this proving chain rule? You're very confusing. You're confusing yourself, really, you know. Why don't you turn off your chain rule? Why don't you cross your chain rule thingy? You don't need this. You don't need the first Desmos, right? You don't need this Desmos, right? Focus, yeah? Focus, please. You don't need this guy, right? Right? So why don't you stick to your Jamboard and stop moving around? I'm going to fulfill your wish of not doing things visually first. Please ask your dy dx to find the gradient, please. Yoko, you have a new question. You're a bit late. Catch up and please, using both Desmos and the presentation.
Okay.
Oh dear. Oh dear. Not very happy. Okay, do you think you can progress, or maybe I give you some hint, Ainesh?
Yeah.
What is the job? I keep repeating myself, right? What is the job that you can ask dy dx to do?
Find the gradient of the tangent, but I don't know how. I don't understand.
At what point?
All the points.
And choose a point.
X equals 1.
Okay, what do you do with x equals to 1 and dy dx? You have located your point, x equals to 1. You have dy dx. So use them both. If that makes sense. That is what you have been doing all along, by the way. And stop writing y equals to 4x. You have dy dx equals to 4x equal minus 3. Stop
I didn't write that. I didn't write that.
You didn't write that? I'm sorry, that is Kyoko, isn't it?
Yeah,
sorry.
Kyoko. All right, so sorry. Just separate yourself, Kyoko, to the other half. So Ainesh, please use them both.
Okay.
You're not finding the gradient, Ainesh. Again, please find the gradient by asking dy dx to do its job. Dy dx and x equals 1. You got your differentiation a bit mistaken.
Yes, I'm doing it.
Where is your substitution of x equals to 1? Where is your working together of dy dx and x equals to 1?
The
Where?
coordinates is a substitution of x equals to 1. I just skipped a step and went straight to the coordinates.
Right. So what is the gradient of the tangent line? What is it? The dy dx doesn't give, never mind. I'm going to read. What is the gradient of the tangent line? The job that dy dx is supposed to do at x equals to 1. The gradient is the gradient is this guy. The gradient is this guy.
How?
Because in Desmos, every time you look at this value, this is what it predicts. This guy is the guy that predicts the gradient. If you don't get that, look back at your previous line and just see for yourself. This guy always predicts the gradient. The Desmos. The previous. Yeah, you have the Desmos from the previous things.
No, I don't. I only have this one. I mean the original one, but I don't have the one from yesterday.
Just go to Desmos. Click on the untitled graph or something. Don't save it. Click on the 3 bars. The 3 bars. Oh, yeah. Okay, thank you. Click that. Okay, let's go to proving chain rule. Right? Okay, open the graph. Right. Which was the original graph? Not that one. Which the dy dx? The last one, right? So, okay. So how did the dy dx predict the gradient using Desmos? Okay, good. You turn off the original one. Good. You look at the dy dx. Good. And the x equals to 2. Good. Which value predicts the gradient? You're pointing at the correct thing. Which value predicts it?
The y.
Yes, the y of dy dx. So, if you look at your Jamboard page 13, am I circling the right thing or not? Am I circling the right thing? There you go. I agree that you don't know how. I totally agree with you, but you have experience on this. That guy keeps predicting the gradient. So even though I want to agree with you that you don't know how, I disagree that you don't know anything. You know something. This guy, that's the gradient.
So the gradient of the equation of the normal is -1.
Why is it -1? This guy is saying 1 what?
No, of course, normal is perpendicular to the tangent, right?
Oh, you're saying normal. I agree with you. I agree with you. Now you have the gradient of the normal. Totally agree with you.
Oh, okay.
Yeah, you have the gradient of the normal. Should be easy from now on to get these 4 marks. This is comparatively very easy compared to yesterday. You're getting the correct things though. Kyoko, are you stuck?
Sorry, I'm doing Desmos.
Oh, good. Doing Desmos is good. You do Desmos first. Ainesh is doing the other way, like no Desmos first. Right? That's totally perfectly fine. As long as you do both. Right?
Okay.
Right. So Keiko, before I was talking to them, I already see that I don't think there's any mistake in your side. I don't think so.
Okay.
Let me think very carefully though.
Now how do I get the y-intercept?
To get a line, this is you learn from GC. Now it's GC. CG time. If you want to get the C, right? So go back to the basics. If you want a line, you need 2 information. Am I correct?
Yeah.
1 information here, you already know. What is it?
The gradient.
Very good. The other information that you will need is
A coordinate.
a coordinate of a point on the line.
Yeah.
Do you have it?
Yes.
What is it?
1, 1.
That would be extremely wrong.
Oh.
You do have it. You are wrong to say that's 1, 1. You're totally wrong. Why is it 1, minus 21?
Because that's the original coordinate.
Point of interest, the point of interest, which is the normal, will pass through that. The tangent will glance that line and the normal will pass through that line. I cannot shake the feeling that something is wrong.
Do I start on the next question?
Yes, please. No, do Desmos first. This is very easy to do Desmos compared to yesterday. So confirm your answer using Desmos.
Felix.
Yes. First, draw the tangent line first, Ainesh. First draw the tangent line first. You have the experience of drawing the tangent line, then draw the normal line. Then you can do a comparison. You have to draw 2 lines. The tangent line, you need a point, right? You need the point and the gradient. You know the gradient of the tangent line, right?
Yeah.
Which is?
1.
So put the m as 1. Set it to 1. 1, yes. Isn't that tangential?
Yeah.
Right? Then make another line. Make another line. Right? Let the gradient be n. Y plus 21 equals to n x minus 1.
I have this.
Yeah, make it n though. Make it n. Yeah, you need the gradient to be different. Just copy paste quickly. Make the m to n so that you can vary it. Now change n to a slider. Change n to the gradient of the normal. Come on, the gradient of the normal is. Now, that is the result that you propose, right? That thing lah.
So what do you want me to do?
I want you to use your Desmos to confirm whether your answer is correct. Does it look correct?
It looks perpendicular.
Right? Is it passing through the point of interest?
Yes.
Yeah, so you must be.
So it's correct then.
Yeah, very good.
Right.
Okay, Kyoko, your question?
How do you find the equation when there's only the x coordinate?
What do you need? What is learned from CG, right? What do you need for a line? You need two information. First information you have is?
The gradient.
Good. The second information that you need is?
Coordinate.
A full coordinate. You're saying you only have half the coordinate, right?
Yeah.
So find the other half, look. It is not difficult at all. Think about it.
Oh, okay.
Oh, I like that. It looks very different. So, Keiko, with some effort, I plot a graph which is different from yours. So I'm just checking why is it different here. Just checking it.
Okay.
So Kyoko, can you do it? Can you find the other half point?
I think so. Wait.
I'm done.
Right. So what is your yeah. Q is minus 20, P is 20. Let me just confirm that you are correct. Let me just confirm it first. Yeah. Yeah. Wait a minute. Oh, it is correct. Yeah, it's correct. Right. So he asked for OPQ. And OPQ, I totally agree, is 45. And your Desmos truly proves it, right?
Yeah.
This suddenly becomes quite an easy question for you, right? Compared to yesterday, right? Are you still of the opinion that the Desmos give you some value?
Yeah. I mean,
What
this
is-
question is a lot easier with Desmos.
I totally get it that you want to do it, sometimes algebra first, right? Totally get that.
Yeah.
I don't mind that. Now I don't mind. You're getting some hang of it. I don't mind. But if you do algebra first, what is the value of doing Desmos for you?
I mean, other than check my answer for some questions, like the first part of this question, there isn't much value. But other than checking my answer,
if I don't give you the answer,
then there's value.
Right. And I will not give you the answer key. At least not for a question I feel is very easy. I feel that this question is very easy.
But my answer is correct.
You have doubts, right?
No, I don't have doubts. I'm just making sure.
If I don't tell you how?
I'll take it as it's correct because I don't see how it could have gone wrong.
For now, I will take your thinking as important, more than my affirmation to you. I'm not sure whether that's affirming or actually the other way around. What do you think?
I think it's fine.
I'll give you another one, similar one, then we proceed to a slightly different question now, if it is possible by today, right? It will still be this thing. It will still be tangent normal. So Kyoko and Ainesh, the type of question here is tangent normal question, if that makes sense to you. Yeah.
Yeah.
So from now on, if I say, hey, this is a tangent normal question, you know what we're talking about, like this kind of thing, right? This kind of thing.
Yeah.
I'm taking the questions from two different papers. What does that mean? It means that, different papers have the same type, tangent normal question. So tangent normal question seems to be, something popular, and I can confirm from your syllabus that that's what you need also, Ainesh. This part, I'm very certain, I'm very certain. Yeah, I'm trying to avoid things that you don't know yet, right?
I mean, you have my school papers as well.
Oh my goodness, why don't we do that, isn't it? Why don't you go to your school paper and you find your own tangent normal question? If you can spot it, that's an improvement, isn't it? You go. Yeah, why don't we do that, right? Why don't? Kyoko, are you done with the first part?
Yeah.
All right. Have you checked with Desmos? Right. Do you think you're correct?
Yes.
Right. Can I not give you the answer key? I know it's nice to have, but can I don't give you?
I'm confident, but I still want to see the answer key.
So why don't you say that you are 90% confident?
Because just to make sure.
I know. Even Ainesh feel that age, right? You want the answer key also, right, Ainesh?
Yeah, I mean, I would prefer.
But
I don't know.
I get that. I get it that you want. Yeah, I get it that you want Ainesh and Kyoko. I get it. Can I not give you?
Yeah.
Kyoko, can I not give you?
Okay.
Right. So I'm saying that I'm taking your thinking as good and important. Right? Why don't you try the second part?
I can't find any questions. Is this?
Go slowly.
Is this a differentiation question?
No, that's an integration one. You don't know how to do that yet. Go up. Go down. Go up. Yeah, no. Down. No. Yeah, no. Nah. Go down. Oh, this is going to be, but you haven't learned this. Then go down. No. Currently, no. Yeah. Currently, no.
Probability.
No, that's statistics. So this is paper.
This is 2020.
No, is in paper 2, is it? Let's go to paper
1 is without calculator, so.
You don't need calculator for a differentiation question. You don't need it.
Oh, that's
right? So
it's probably likely to be here.
Right. So let's find out. No, it's not it. Okay, no, that's not it. The statistics, that is still probably not it. What is this? No, that's not transformation. This is not, they like statistics a lot, isn't it? My goodness, right?
Yeah.
No.
More probability? Is it?
No, this is binomial, something that you have not learned, I guess.
Oh, I've heard of it.
But no, you cannot do it yet. No, also no.
Oh, partial.
True. Your paper is weird, isn't it? As in weird to me. It's not weird to you, right? It's not. It's weird to me, right? Go down. But they mentioned tangent in circle. You have not learned circle, so you cannot do that.
Where is he?
Right?
Oh,
Right. So there is lah, but let's just go on. Let's just go on. You cannot do this yet.
no.
Oh, let's stop here. This is the last one. Let's stop here. So I'm just looking at. Oh, is the last question. Is the last question, but they phrase it in a way that you have to integrate instead of differentiate. And you cannot integrate this.
So once you learn integration, we can do questions from this paper.
True. However, integration is more difficult than differentiation. That has always been the case. In this case, it'll take some time before you can do it.
I see.
It'll take some time. Just some time, no, not a lot of time, but some time. So you cannot do this. You cannot do this question yet, lah. You cannot do this. Right?
Okay.
Right. Let's try one more paper. You check by yourself first. Check by yourself first. You may want to search the word tangent. That's a shortcut way of searching. Right. Maybe you'll find one, right? Right. So Keiko, I haven't found any mistake from my side, but I'm just trying to be sure, yeah, before I show you the graph, right? Do you have any other question with whoa. Do you have any question before this? New one? Oh, there is a new one, is it?
For the previous question or this question?
No, sorry, I was asking Keiko. But Kyoko, can you do the second one?
I don't know how to like explain in presentation format, but when I draw it out, I can see why.
What is the answer?
45.
Correct. So never mind. For now, never mind.
Oh,
Really.
okay.
Never mind. Right. For Ines, you choose to explain it as isosceles. I think that's acceptable. I'm so sorry. You cannot just say isosceles, but you must say that it's also 90 degrees. So Ines' explanation is not full. It's half of it. You must say that one of the angle is 90 degrees. Then it will be 45. But for now, Kyoko and Ines, if you can see it, I'm happy with it. I'm happy. Okay. Right.
Oh.
Right. So Ines, back to your searching of questions. If you cannot find it, then I will give you a new one. Better that way.
This was the only one a tangent. This does not look like the questions we did.
However, this is not the tangent normal that we're looking at. It's not.
Yeah.
Okay, so let's go down. No, not this one. No, this one. Not this one.
What is this even?
No, not. Yeah, no. You have statistics. No.
Oh.
No. Okay, no. Let's go to question 7. Quickly. No, yeah, no. Every question you have your pass through don't have it. Even this is not what you do with differentiation. It is something else. But it just shows you that the concept of tangent is everywhere. So it's good for you to see it visually. Every time they mention tangent, it is, I think, very visual. So maybe you consider it as a requirement to at least imagine it. Now go down. They have maximum, minimum, but you cannot do it yet. Go down. No, also no. Just go. Yeah. No, yeah, this is your trigo, also cannot. So no, it will be a cosine if it'll be a trigo sketching thing. Yeah, so no tangent normal for both of you, right? So no tangent.
Yeah.
I'm going to show you a maximum minimum question, and then I think that's the end for today. Please wait for the question, yeah? So Puka and Anes, this is a similar question. This will be the last tangent normal question that we do. So do you see the new question at page 15?
Yeah.
Right. Now, I have to tell you something first, Kyoko and Ainesh, because we haven't talked about this, right? So, now. Right. So I have to tell you something first, yeah, Ainesh and Kyoko. The differentiation of ln x, as you see here, is 1 over x. This is extremely weird and not making any sense at all. However, if I ask you to prove it in Desmos, it will be correct. Okay? This is something new. So far, so good? Now, you need to differentiate this. At this point, you have the knowledge to understand that. Why do you need to differentiate this? Somebody answer. Are we at page 15? Kyoko? Ainesh, how come? Sorry, Kyoko, Ainesh, are you there?
Yeah.
Right,
Yeah.
Kyoko, are you there? Ainesh, are you there? Sorry.
Yeah.
Okay, Kyoko, why do we need to differentiate this? I'm not saying that you can differentiate it. That's not what I'm saying. I'm not asking you to find out the result of the diffusion. I'm asking you a more important question. Why do we need to differentiate this?
Because it's not aligned.
From all the questions that you have done, what do you learn about the job of dy dx?
To find the gradient of
the tangent line,
Yeah.
right? Now, this question is clearly asking you for the tangent line, right?
Yeah.
Would you need the gradient of that line?
Yes.
Then why do you need to differentiate it?
Because we need to find the gradient.
If that makes sense to you.
So
why am I telling you this, Ainesh?
So that you can find out the gradient of the tangent.
Because you will need it to differentiate this. That's the gradient, right?
Yeah.
So when you want to differentiate this, the first thing you should ask is, do you need a rule or not? Well, do you need a rule or not, Ainesh?
You mean this rule?
No, I don't mean this. The new one, guarantee you need. That's not
Yeah.
a rule. That's something basic already. But I forgot to tell you. Let's just say that. So I am giving you something basic that you need to know. When I ask rule, I refer to the 3 rules that we learned.
Oh, chain. We'll need chain.
You need chain. Yeah, I don't disagree, but you think you think you need something else besides chain.
Product rule.
But there is no product here. Product as in times. You need the other one.
Quotient.
Yeah, because quotient rule is meant for what?
Wait, no, but there is product.
Product of?
You can just do 3x plus 1 plus 11.
Oh, you want that? I totally agree.
Yes.
Do you remember the product rule?
I mean, I have it in front of me, but yeah, I do.
No problem. Now, preference, Kyoko, would you like to do product rule or would you like to do the other guy, which is quotient rule for division? Which one do you want? Kyoko?
How do you do product rule?
I have it here.
Like, I don't see a way to do product rule.
Then even though you may want to, you cannot lah. Let's just see how Anish do it. Fair enough, right? But then therefore your only option is to do
quotient.
All right, so I'll give you the quotient rule, okay? This is product rule. Then you can learn from Anish if he does it successfully, right? So the quotient rule will be this. Again, you don't know why, but this will be true, right? Okay. So at this point, you may want to copy it to the next question, to the next page. So before that, Keiko, let me answer your new questions. I've read through. So what is your question here?
I have dy dx already, but
the Cartesian.
I don't know exactly what am I supposed to do with it after.
Right. If you want the Cartesian equation, it's probably best not to do it from dy dx because the dy dx.
It's part one.
Oh, part one.
Yeah.
Okay, sure, right. So, no. And passes. Wait. So, do you have point A? I'm very unclear what point A is. How come he suddenly say that going on here? What is point A? Okay, let's assume point A can be anywhere lah. So it's a bit useless lah, yeah. Currently lah. But he said that the line passes through the origin O.
Yes.
Wait, that's not. Let me think for a while. Is that helpful? Wait, let me think for a while. Right, so what I can say to you is this. Okay, go yeah. So y equals to mx plus c, right?
Yes.
Right? You can put this in terms of t, right? You now also have this in terms of t, right? You do.
So
correct. You have it in terms of t, you have this in terms of t, you have this in terms of t, and the only contribution that origin makes, is that this will be 0 lah, right? That's the only contribution. So currently, even though this is not what you usually do, if you write it down, you will realize that this is somehow one equation and one unknown, somehow. Which means it is solvable, right? It is solvable.
Okay.
So you have a t, at A. It is extremely weird, I agree with you, but this is not unheard of in parametric. Like it just makes us a little bit confused. So you found the t at A, and then it's kind of a downhill from there, quite easy,
Yeah.
Right. Okay. I guess get used to the logic, right?
Yeah, sure.
Right.
For me, that's all already.
Understand. So I still owe you that question, right? I'm just going to confirm very slowly that I'm doing correct. Then I'll just send you the picture from WhatsApp. Okay.
Okay.
Should be easy, right? I take it that you can test another paper this week, and then I'll see you with that paper next Sunday.
Then tomorrow don't have lesson?
Yeah. I didn't message you, isn't it? No, tomorrow don't have lesson. Tomorrow because I have a family family event.
Oh, okay, okay.
What is my question? Oh, right. My last question is, have you marked your Nanyang paper?
I've marked 3 of them.
You have what, sorry?
I marked 3 of them only. But I think I've told you the scores already.
You have no, you haven't. Unless I miss it just now.
I told you like some time ago. There's 1C, 1A, 1B.
Oh, this is not the Nanyang paper, which is what we read yesterday. No, this is the old Nanyang paper.
Oh, you mean this paper? I haven't marked this one.
Then just mark it, and then you just tell me on Sunday. Just want to know, and then you do a new paper, also mark that one.
Okay.
All right. Okay. I will send you what. Okay. Right. So, Ainesh, I get it that you wait. So, Ainesh, what you're doing is wrong. So I have to stop you right now.
Yeah, I know.
Clearly is wrong. So you're saying that why is this? I totally don't get the logic from here going to here. Now, how did you do that?
No, as in the product rule, I'm using the product rule for the 3x plus 1 square. Did I do it wrong?
Oh my goodness. Let's say you're correct, right? Let's just say you're correct first. Your problem is here, you don't use any rule. So let's say that you're correct on top. I get what you're doing. You're wrong here. This is wrong. But why?
Why?
You're saying that the dy dx of this is you just differentiate the top and then you just differentiate the bottom. That you to get totally wrong, really. That you're just wrong. But if you want to know why, you go to Desmos and you'll see for yourself that you're totally wrong. Plus, going from here to here is also wrong. But this is just wrong. This part is just wrong. If you put in Desmos, it will be wrong.
Okay.
This is something over something. This is something over something. When we were doing page, look at page 4, Anish, right? Look at page 4. Are you there?
Yeah.
Which part am I circling?
The second one.
Right. So when we were doing that, did we differentiate this? And then the result is this become cosine x over minus sinus x. Did we do it that way? Do you have some idea of what we did?
No.
Right. So I suggest that you look at page 5. Which one is your working?
The blue one.
Right. Do you see that question? This one, right?
Yeah.
That's your original equation. And then suddenly your dy dx is not as simple as cosine x over minus sine x, correct? Correct.
What am I doing?
Of course, you don't really know.
Product rule. This isn't product rule.
This is quotient rule, yes. Because quotient rule is meant for division, if that makes sense. This is quotient rule. This is not product. That's why I keep asking. Right. So Kyoko was saying that I don't know how to do product rule. She wants quotient rule. So she did quotient rule with our new question. So I suggest that you should do that also.
Yeah, okay. I did not understand what I was doing.
Right. I'm not saying that quotient rule makes sense. It does not. I have to keep reminding you. But after a while, it should sink in. Oh, goodness me, I should be using some sort of rule. That's what I'm asking of you. Oh, goodness me, I think I need to use a rule here, something like that.
Okay.
Yoko, are you okay so far?
Am I supposed to use chain rule for the
3x plus 1 square. Yeah, it's not complicated. I would argue lah. It's not. But yeah, you're supposed to. Yeah, you're supposed to. And if you cannot do it directly, I suggest that you do it on the side lah. That's always a good thing, right? You shouldn't force yourself to just do everything at one go. Do you understand? You should find your v prime first lah. Okay?
Yeah.
So do it on the side, find your v prime. So Anish, where are you doing this?
I'm erasing my old working.
Oh. Yeah, Anish. Oh, now I'm seeing you. Right.
Yeah.
Right. So Kyoko, let's go back to your chain rule, yeah. Let's just go back there. Let's stop here. Now this is your v, right?
Yeah.
V equals to 3x plus 1 square. It doesn't look like you apply chain rule here. It really does not. It's like you ignore the chain rule totally. Okay. If you put this in decimals, it will be wrong. Okay. Can we agree first that you don't apply chain rule at all here? I don't think that's what you did. Okay. Let's go through chain rule one more time. It does not make sense, but you need to memorize.
What do you put v square on the bottom of the?
It is v square. It is a weird thing, but v square is correct.
So it'll be 3x plus 1 whole square square.
Yes, you are correct. So to the power of 4.
Yeah.
Correct. As weird as that sounds, you don't have to simplify that. You'll be just fine if you leave it like that. So the only problem you have is the v prime. You need to find the v prime separately, but you already have the v prime. Just now you erase the v prime. See, I think your v prime is correct.
No.
Yeah, so I don't know why you erase everything, but you can just, I don't know, just redo it lah. You seem quite fast. Now, Kyoko, chain rule, yeah? What's the first step of chain rule? If you forget, please refer to yesterday's working.
Wait,
What is
hold on,
the first step of chain?
Sorry. For V prime, you mean using the product rule, right?
You can use product rule, you can use chain rule, by the way.
I'll use product rule, easier.
Product rule, no problem. Chain rule also can, that's up to you. Now, Kyoko, what is the first step of chain rule?
V times V prime.
That's totally not the first step of chain rule. Totally not. If you go, let's look at page. Let's go page 9, okay? Let's go page 9. Okay, are you there?
Yeah.
Okay, so look at this. This is the first step. What is the first step?
The U.
Say the verb. Pretend. Pretend that the inside is?
The U.
Right. Why? Because second step. Second step is you can differentiate because it looks basic. Repeat after me. The second step is?
Basic.
You can differentiate because then it looks basic. Okay. The third step is times U prime. Okay, what's the first step? Pretend.
Yeah.
Pretend that the inside is?
U.
What's the first step?
Pretend the inside is U.
All right. Second step?
Differentiate.
Because now it looks?
Basic.
The third step?
Times U prime.
Does 1, 2, 3 make any sense or not? It does not. It does not make sense. This is the worst part of differentiation. It doesn't make sense in algebra. It only makes sense visually. And they don't give you visuals. So Kyoko, I apologize. You do have to memorize the steps until it becomes part of you. Okay? Now, let's go back to page 16. I promise you this will be correct in Desmos, not in writing though. Right? Okay, that has always been what I said from the start. Now, can you pretend the inside to be you in this case? Don't do that because it will confuse you because you already have another you. Understand? So just pretend the inside to be something, some other letter, right? No problem, right? For example, W. That's okay. That is your first step. What is your second step?
Differentiate.
Because it looks basic. Go ahead. Right. So Ainesh, I do suggest that you stop here though. I suggest that you don't simplify. There is no point in simplifying. Do you understand what I'm saying? Why not? Why is a waste of time to simplify?
Because I don't know, but I don't know what I'm supposed to do.
Okay, let's stop here. What's the job of dy dx? Keep asking you until you get it. What's the job of dy dx?
Find the gradient of the tangent.
At where?
All the points.
In this case, what is the point you want?
X equals to 1.
Yeah, with whatever y it is, you can find that if you want. So can you already find the gradient? This is a form which is complicated, right? It doesn't look nice, okay? I'll be the first to admit. Can you use this not nice form to find the gradient?
Okay.
Can you? Or rather, maybe you want to try. What's your answer here?
Just sub in all the x. Yeah, I can.
So why bother simplifying, right? Right. So go and find it. Go and find it.
Okay.
Kyoko, you are stuck, yes? Kyoko?
Yes.
Your first step is to pretend that the inside is W, correct?
Yeah.
Second step is?
Differentiate.
Because it now looks?
BC.
What's the differentiation of W squared? You have no idea?
No.
Right. What's the differentiation of X squared? Kyoko, what's the differentiation of X squared? Kyoko, what's the differentiation of X squared?
I don't remember.
The differentiation of X squared is? No. Are you still feeling sick?
No.
The differentiation of X squared is the power from 2 becomes?
Zero. Yeah. 1.
Come on. Yes, 1. And in front, there's a 1 here, right? So the 1 stays, but times somebody else. Who is it?
2.
2. So the differentiation of X squared is?
2x.
You okay? Does this make sense? It does not. It's just following a pattern. It's the most frustrating thing with differentiation integration. If you test this in Desmos, what will happen?
Correct.
It will be correct. Okay, so what's the differentiation of W squared?
2W.
Write that down. That's the second step. So Ainesh, what do we have? You're just using your calculator, right?
Oh no, I'm gonna write it down.
No, that's your second step, Kyoko. What's the third step?
Times the prime of 2W.
The prime of W. Just write down the prime of W times W prime. Write down. This is dv dx, by the way, not dy dx, because you're differentiating v, right? Right. So there is a fourth step. What's the fourth step?
Substitution.
Yeah, to go back to x. So please do that. Ainesh, this is a bit too slow, right? Just inputting 1, right? What's going on here?
I'm typing in the calculator.
I guess doing it manually does give an advantage, but this is a little bit, just a little bit too slow. 1 more minute, Ainesh. If not, we'll do it manually. 1 more minute. Too slow already, yeah? Too slow.
Yeah.
Yoko, are you stuck? What is W?
3x plus
1, right? So go and write it down. Equals to 2 times that. Write it down. Then times W prime. What is W prime? The differentiation of +1 is?
0.
The differentiation of 3x is?
Uh,
The differentiation of 3x is?
X.
The differentiation of 3x is?
1 over x.
Oh, come on. No, this doesn't make sense. I know. But the power becomes? The power becomes?
-1.
No, 1 becomes? Come on. 1 becomes?
0.
0, 0. And then there's a 3 inside times what? 3 outside times? 1, right? So the differential of 3x is?
Yeah, 1. It's 3 times 0. No, 1.
No, x to the power 0 is?
1.
1. So the differential of 3x is?
1.
X to the power of 1 become x to the power of 0. What is x to the power of 0?
1.
What happens to the 3? It's there, right? The 3 stays, right? And then 1. 1 is here, the power. That's the pattern, right? The pattern like that. 1 goes like that, and then this becomes 1. So 1 times 3 times x to the power of 0 is equal to? Okay, so the differential of 3x is? Does this make sense?
Yeah.
It does not, but please memorize the pattern. I know it doesn't make sense, but you got to remember the pattern or look at your previous working. Okay? So complete your dv/dx, please. Yeah, I agree with the 1 over 16. Okay. Right. So where does this one comes from? Oh my goodness, where does this one come from? Where does this one come from?
The first equation.
I totally agree with the 0 though. So I guess I like that. I like this for now. Yeah, your C is not 1. I don't get how that becomes 1. How did C becomes 1?
That's the y-intercept, right?
You say that you're not a visual person. I think there's a weakness here. At this point, I really think that there is a weakness. So how does y-intercept look like? I think this is really a weakness at this point. How does y-intercept look like?
When the line... Oh, wait, yeah, okay, that's not the y-intercept.
Okay, good. So go and find the C, please. All right, so Kyoko, are you continuing with the quotient rule? Continue with the quotient rule, please. Right. Okay, good. No. Right. Nice. Yes. Very good. Yes. Right. Okay. So far, so good. Right. Then completing the product. Okay. So Ines, what's the C? Come on, Ainesh. This is too long. What are you doing? What is the C?
So you assume everything on x is 0?
Oh, goodness me.
Oh, okay. No,
Stop thinking what you're doing. You should be thinking about what, goodness me. To form a line, you need two information. First information is,
the chords. I know.
then the second information is the gradients. How do you use them? Prove your answer in Desmos. Now for Desmos, you usually put four things, right? Usually put the original one, the dy dx, the line, and whatever x equals to, right?
Yeah.
Right? So why don't you just put the original? You don't need to put the dy dx. Just put the original, the line x equals to 1. Do it in your Desmos. Are you done with your dy dx? Are you done with your dy dx?
No.
Do you want to repeat the v prime? Is that what you want to do?
Yeah, because the denominator has a square.
Is that a problem? Why is it a problem? Why does it feel like a problem?
Because it's
So Ainesh, the line is not tangential, right? It's not, right? It's not glancing the curve, right? Correct? That's because something is wrong. Okay? Gonna ask you to do the product rule one more time. Okay? This one you just have to write it down. Okay? Just write down the product rule one more time. I don't mind you using product rule, but I think it's wrong. Okay, Kyoko, I'm going to stop you here. Yeah? You're trying to simplify, isn't it? Why do you have to simplify? You think carefully, right? You think carefully. Just think oh, goodness me. You just simplified this with this. Oh, goodness me. You keep doing the same mistake. You keep doing the same mistake. You keep doing this mistake. You keep doing this mistake. You keep doing this mistake. Can you simplify like that?
no.
Why cannot? Because of the minus sign. This is not times. If this is times, you can. If this is minus, you cannot. Do you understand? If you don't understand, at least tell me. Do you understand that you cannot simplify this or not?
Yeah.
Because you keep doing it. There is something in your mind that asks you to simplify no matter the cost. It's a big problem. Second question, do you need to simplify? I'll change the question. Do you want to simplify?
Yeah.
You don't need, however, to simplify. That is a good news. I explain why. What is the job of dy dx? Where's my product rule, Ainesh? Write down my product rule, please.
Okay.
Oh goodness, you guys. Kyoko, what's the job of dy dx?
To find the gradient
Of the
and tangent
where?
the curve.
At any point or at some point or what?
Any point.
Correct. In this case, what point you want?
X equal 1.
Now, do you need to simplify to get what you want? Yes, no, not sure.
No,
Why not?
because you can sub in the x.
Correct. Think carefully. Is that making you happy or unhappy? You don't have to simplify to get what you want. Does it make you feel happy, unhappy, weird, don't know, whatever?
Happy.
Then don't simplify, even in exam. That is the right thing to do. I'm not saying this because you are not good at simplifying. You are not good, at least in this situation. But I'm not saying that because you're not good. I'm saying that because you will save a lot of time in exam if you don't simplify. That's a very good reason in my experience. Do you understand why I'm advocating not simplifying, Kyoko?
Yeah.
Because
Save time.
in
Exactly.
oh, very good. Now we won't discuss your mistake. Just go back to the non-simplified mode, please. So Ainesh, I'm still not getting my product rule, isn't it? I'm shouting and I'm still not getting it, isn't it?
No, what do you mean a product rule?
How do you get 55x plus 18? By product rule, right?
54, yeah.
So get me that product rule.
You want me to do the product rule out?
Yeah, so that I can point out that there might be a mistake. Because your Desmos say that there seems to be a mistake. Every time we do it correct, Desmos says you're correct. This time, something is up. Please do your product rule. Come on. I've been shouting for 5 minutes. Now, I'm going to ask you something. What is 9 doing there? As in, why do you put 9 there? Nine must be u prime, isn't it? That's what you're thinking. Something like that?
Yeah, but it's not.
So what is u prime?
3.
Very good. Thank you very much. Does the product rule make any sense?
No.
No.
It's a law.
Totally. I sympathize with you. I was never angry when you do it wrong, the rules, because it doesn't make sense. But I am very frustrated when you don't think or you don't even do what I ask you to do. Never mind. So just try to fix that. The rule doesn't make sense doesn't mean that everything doesn't make sense, right? To preserve your sanity, a lot of things must still make sense, right? So change, just go and find your new dy dx, please. Now at this point, this is very good to do just very good to do a manual work. Come, Ainesh, you're gonna do manual work, okay? You're gonna do manual work. This is 1/1, right?
Yeah.
Right? What is 3 times 1?
3.
Plus 1?
4.
Now here's a surprise. What's ln 1? Just type your calculator. Ln 1
is 0.
Yeah, so everything here is 0, right?
Yeah.
What's the bottom one? Don't tell me you have to press a calculator. Don't tell me that, please. The bottom guy is?
I mean, it's 4 to the power of 4. So
Very good. 4 to the power of 4. So 4 to the square over 4 to the power of 4. Use manual work. What is it?
256.
Come on. 4 square over 4. You're in this guy. You have been practicing in this for a long time. Come on.
It's 1/16.
Thank you. It's still 1/16, right? So what else do you have to fix?
It's correct.
I mean, somehow your mistake doesn't matter yet.
The ln x saved me.
Yeah, the ln x did save you. The Desmos is still a very big curiosity. The Desmos should have shown you that you're correct. This is not okay, lah. This Desmos is not okay, It's really not okay, Kiko, what's ln 1? Just press your calculator. Ln 1 will be
0.
Right? So here is just 0, right? Now, why is your denominator disappearing? Why did your denominator disappear? You should have a denominator there, right?
Mm.
So, Manish, I take it that you do not know what's going on here, right? Something is wrong, but it's very unclear where, right?
Yeah.
Right? Well, first thing first, the graph doesn't seem to be 1, 0. It's very weird, right? The graph should have been 1, 0. That graph is weird that way, right? The graph should have been 1, 0. Either your calculator is wrong or your Desmos is wrong. So I will suggest you that you will bracket your ln x. Maybe something weird happened in Desmos. Bracket it just to make sure that it is okay. Bracket. Yeah. Did the graph change?
Yeah.
Right. Maybe Desmos was messing with you, right? You weren't messing with Desmos. You were doing it with honest intention. Now zoom in that point, please, and just make sure that it is tangential. So as you good. So you were correct, but I have to correct your mistake, lah. You're gonna be not gonna be so lucky next time. Huh? You understand what I'm saying, right? Okay. So you were correct. You were correct. Right. It was an honest mistake, lah. Especially when it's a mistake, it's a rule mistake. You take time to use it. In general, your flow of thought is correct. Even your Desmos.
Yeah.
That was Desmos messing with you, not you doing it wrong. Okay. Now, when you look at Desmos and you breathe a sigh of relief, oh, you are correct. That means you understand Desmos. Look.
Yeah.
I would argue that this question is also not very difficult. It's just more rules also. It's good to practice them. Okay.
Yeah. Cause I mean, if I knew my stuff and if I knew ln x was ln 1 was gonna be 0, then I wouldn't have to use the product rule, and then the question would have been easier than the previous one.
However, I'm just a little bit, this is a little bit disappointed because ln 1 equals to 0 is something that should have been brought forward from the log stuff. It's a little bit, just a little bit disappointed. Not a lot.
I just didn't think of it.
Correct. If you think of it, it does make your life easier. So in some sense, manual work is not bad, yeah? In some sense. You don't like the typing of the calculator, right?
Yeah.
Neither do I. I do think that manual work has its place. I do think. But in this case, it is making our life easier. I will argue. So, good experience. You guys are so slow, but I think it's still a good experience. Right? I won't see you guys tomorrow, okay? Manish, I won't see you tomorrow. Right? I'll see you on Sunday. Right?
No, you won't.
I'm sorry. Oh, Sunday you won't. Sunday you'll be off.
Yeah. I
Can't say I'm
think maybe
satisfied. Can't say I'm
Tuesday or
satisfied.
something. I'm not
Yeah,
sure.
you go lah. You go. Just go. If someday you can make it, please make it. It's not like your advance is groundbreaking lah. It's not. Okay. If you cannot, then just go. Just enjoy your holiday. Okay.
Oh, yeah, I don't think there's any chance at all I can make it on Sunday.
No problem.
Yeah.
Okay. I'll see you when I see you lah. Okay.
All right. Bye. Have a
Bye-bye.
good night.
You now Kyoko. Right. What is 16 over 256? You can simplify it. Come on.
1/2.
No. Just press calculate. Just press calculate. Come on. I know this is not mentally easy, but just proceed until you see your Desmos confirming that you're correct. At least stop there. Okay? At least stop. Now, what do you have here? What is 1 over 16?
The differentiation graph.
No. The differentiation graph is here. Here. You have it here. What is 1 over 16? That's something more than that. That was the job of dy dx, right?
Gradient.
To find the gradient at what point? At this point, the point is
X
equals to 1, right? So what is 1 over 16?
Y coordinate.
The gradient at x equals to 1. The gradient at x equals to 1, because that's the job of dy dx. Every time you do Desmos, that's what the guy predicts. Right? I'll say the nicest thing. It's very difficult to imagine what's happening algebra-wise, right? What the heck is this? We just forget, right? In Desmos, it is easier, right? However, your teacher will ask you to do this. So please remember your Desmos and remember, 1 over 16 is what?
The gradient.
That he is supposed to predict, right? Right? So DDoS is doing his job predicting the gradient. Now after this, what do you do? You want to find the what?
The equation.
For to find the equation of a line, you need two things. What are they?
Coordinate and gradient.
What do you have right now? Okay. What do you have?
The gradient.
I know. And then, do you have the point? Do you have the point?
Yes.
Really? You have the point? Really? You have half the point. Same problem as just now, right? You have half a point. Is that enough to find the line?
No.
Okay, can you find the other half? Okay, what is ln 1? Yeah, what is ln 1? Yeah, at this point, you know the answer will be
0.
Yeah. The bottom one doesn't matter, right? So now, do you have the point? Okay, then can you find the line? Yeah, so what is C? Finding C is finding the line. Go to Desmos and see whether you're correct or not. Now, in Desmos, you usually do 4 things, right? The original, the dy dx, the x equals to 1, and the tangent line, correct?
Yeah.
I'm asking you to not type this guy. This is a lot to type anyway. I'm just asking you to type 3 things. The original, the x equals to 1, and this. Understand? Go to Desmos. Show that you're right or wrong, whichever that will be.
How do you do non?
Just type ln. Can you type ln? Just use your keyboard. Yeah, use that. Yeah, just type ln. It will understand it. It will understand it. Right? Yeah. That is an ln. There's a lot. Yeah. Actually, quite. Where's the x? Kyoko, where's the x? Your line. Now zoom in to see whether it is actually tangential or not. Is it glancing or not? As you zoom in even more, you become more or less convinced that it is tangent. Is it glancing?
Yes.
All right. What do you think then? What's your conclusion?
Accurate.
Okay. In this case, your Desmos work is shorter, right? Because you don't have to dy dx, correct or not? You don't have to type the dy dx, is what I'm trying to say.
Yeah.
Usually, I ask you to type just to show you the full logic. Here, do you miss anything if you don't type the dy dx? Do you miss anything?
No.
Correct, right? Usually I do ask you to type this thing in Desmos, right? Usually, right? Correct or not?
Yeah.
Now you don't. Are you sure your Desmos is still telling you that you're correct?
Not really.
Look at your Desmos one more time. You have the original graph, right? And then you have your line, right? You have your line. In fact, if you make the x equals to 1 invisible, you also can. No, never mind. No need to do that. That's just good for the point. Yes, that's good. Right. Oh, actually, it is. No. Actually, it is good. Make the line invisible. Make the line invisible. Make the x equals to 1. So what happens here is that you have an intersection between the line and the curve, right? So find the intersection, you just tap on it. No, you just tap on it. There. When you tap it like that, the intersection, the intersection 1, 0. Stop moving. Yeah, stop moving. Let's say you only have two things, your original curve and your proposed answer, the line, correct? Is Desmos telling you that you answer the question? The question is, read the question. The question is, the equation of the curve is this. Find the equation of the, go to page 15. Okay. Did you solve what the question wants, according to Desmos?
Yes.
Yes, correct. So from now on, if you do if you do the dy dx manually, you always have to do it manually, right? You have to find this manually, right? You don't necessarily have to type in the Desmos. You don't necessarily have to do that. Right? Then your Desmos checking become much faster. You're just using Desmos for checking now because you're already at a certain level where you understand something. Right? You do understand something already. Okay. Right. Now, can you live in peace? I never give you the answer key. Can you sleep in peace?
Yes.
Okay. Why are you so slow today at INS? Same thing. I don't know. But I think you guys still learn something. I hope so. Okay, because Desmos say you're correct. Okay. I'm frustrated, but at least when you see Desmos, you are somewhat happy. Yeah. Okay, Kyoko, I won't see you tomorrow. Right? I'll see you next Sunday. Okay. Bye-bye.
Bye-bye.